Okay, so this is lesson 2 on the sine rule. This lesson will cover finding an angle using the sine rule. So the lesson objective is to be able to find the missing angle of a triangle using the sine rule. You will need a calculator, of course, for this lesson. So, just to recap really, what is the sine rule? So the sine rule up to now has been looking like that. That's what you've been using. We use this version when we're finding sides. So if you're finding sides with the sine rule, you put the sides at the top. If you're finding angles, however, you put the angles at the top. Okay, so today we are going to be using this version of the sine rule because we're finding angles. Okay, now this does mean that it adds a step on the end of our sort of normal procedure. So up to now we just end up with an answer after, I think we divide two things and then times it by one other term, and then you get an answer for A, B or C. This time though, to work out angle A or angle B or angle C, you're going to have to undo the sine function. Now the way to undo the sine function, as you'll remember from normal trigonometry, is to press on your calculator shift and sine, which is sine to the -1. Now that may not make a huge amount of sense right now, but let's look at it with a question and hopefully it will make more sense. So here's a question. Question reads, find the missing angle, angle theta. You're given some information here about the triangle. Question 1 for yourself really is it a right angle triangle? And looking at the diagram, it's not. Even if it looked like it was, it says not to scale, so you can't assume it's right angled. So the answer is no, it's not right angled. Then question 2, do you have a matching angle and side? And remember, by matching I mean opposite angle and side, and the answer is yes, I do. 72 degrees and 10 centimeters are matching, so I can use the sine rule. Now like I said, the sine rule this time is going to look a little bit different. This is what the rule looks like now. We're going to use angles at the top, so sine A divided by A is equal to sine B divided by B. So substitute what we've got. Sine theta, theta being this unknown. If you prefer, of course, you can call it x if you like. I'm going to leave it as theta for the time being, but you can call it x if you like. So sine theta divided by 7.1 is equal to sine 72 divided by 10. Now looking at that in the same way as before, we were saying, right, how do you get the bit on its own? How do I get sine theta on its own? What do I need to multiply both sides by? The answer is you multiply by 7.1. So if you multiply by 7.1, that will leave you with sine theta equals sine 72 over 10 times 7.1. Here's where you pick up a calculator and you actually put this in your calculator. So sine 72 divided by 10 and then answer times 7.1 gives you that. Now I don't know about you, but this angle looks a lot bigger than 0.67 degrees. That is because my answer at the moment isn't the angle. My answer is sine the angle. Sine theta is that. So how do I get rid of sine? You should remember from basic trigonometry, you use the inverse of sine, which is sine to the -1. So that's what you put in your calculator. Sine -1, 0.67, etc. Press equals, and you've got your answer there. Theta equals 42.473576, etc. Now finally, again, it doesn't tell you to round the answer. However, it is good practice, standard practice, to round answers like this, and typically you round it to 3 significant figures, or maybe sometimes 2 decimal places, and you should remember your units. So I'm going to do 2 decimal places, and there's my answer. Okay, next. Here is a question for you to try. Please have a go now, pause the video and try it yourself. So running through the question then, ask yourself the normal questions. 1, is it right angled? No, it's not. 2, is there a matching pair? Yes, there is, B and B. So I'm going to write down my sine rule as sine b over b is equal to sine a over a. I've written it this way around this time, guys, and the reason I've done that, you'll notice I've swapped the two. Normally it's a first and b second, because b is the one I've got, so you know the matching pair that I've got, I'll put that first. So plug in the numbers. That's what it'll look like. Sine 46 divided by 12 equals sine theta divided by 10. Now again, ask yourself, looking at this equation, or this expression, what do I need to do to both sides to get sine theta on its own? This is a divide by 10, remember. So what is the inverse of divide by 10? And the answer is multiply by 10. So multiply both sides by 10. That will give you sine 46 over 12 times by 10. And sine theta is now on its own. Here's where we pick up the calculator. Sine theta is this big long horrible decimal. Remember, how do I turn that into the angle on its own? At the moment it says sine theta is this. What's the inverse of sine, the opposite of sine? You press shift and sine, which is sine to the minus 1, giving you 36.8305, etc. Again, we'll round that answer. Oh, apologies, I clearly didn't round that answer, but we should round that answer to 36.8 or 36.83, depending on what the question tells you. In this case, it doesn't tell you, so it's up to you. But I'd go with 36.8 or 36.83. Okay, now here are 4 basic questions for you to try. All of these questions here rely on using the method we've just gone through. You've seen one example and a second question which I've gone through the answer for. You need to work out the angle theta in each question and round your answer to 1 dp. The green task, for those students looking for a little bit more of a challenge, this question you don't have a drawn diagram, so my advice here really is draw your own diagram basically. Okay, so you're given the measurements of a non-right angled triangle. You've got 2 of the sides, you know 1 of the angles, you don't know angle B, and obviously you don't know angle C. So if I were you for this question, draw it out and have a go labeling it and using the method we've just learned. As usual, you will need to take a picture of this, the answers to these questions, and upload it to class charts in order to complete this homework for today, or this remote learning, apologies, for today's lesson. Thank you very much. Good luck with that.